Good morning, my name is Jimena Ugalde and this is my team, Hanna Villarreal and Ana Maria Valenzuela. We are talking about the black holes. The objective of our team is to understand what is a black hole and know a little about its functions. The question is, can you see a black hole? But first, what is a black hole? A black hole is anything but empty space. It is a great amount of matter packed into a very small area. Think of a star 10 times more massive than the Sun, squeezed into a sphere approximately the diameter of New York City. The result is a gravitational field so strong that nothing, not even light, can escape. This is the definition of a black hole. In this picture, we can see all of the parts of a black hole, and I'm talking about the description of each one. I'm start with the particle jet. What is a particle jet? Or relativistic jet are beams of ionistic matter accelerate close to the speed of light. Most has been observationally associated with central black holes of some active galaxies, radiogalaxies, or quasars, are marked by galaxy stellar black holes, neutral stars, or pulsars. This is the definition of a particle jet. What is a accretion disk? Accretion disk is a structure formed by diffuse material in orbital motion around a massive central body. The central body is typically by stars. Friction causes orbiting material in the disk to spiral inward toward the central body. This is the definition of a accretion disk. Okay, what is a X-ray emitting hotspot? Its astrophysical X-ray sources are astronomical objects with physical properties which result in the emission of X-rays. We can see in the picture the parts of the black hole. We can see the particle jet. We can see the accretion disk. It's like a circumference. And the X-ray emitting hotspot. We can see a light, but it's not a light. My partner will tell you a little more about this topic. Thank you.
Its gravity can absorb near matter are supermassive and superdense objects in the universe. Due to these properties, strong gravitational and electromagnetic forces. Thanks to these forces, we know they exist because we cannot see them. They are energy gamma rays. Space-time curves infinitely where physics doesn't exist. Matter tells space-time how to bend and space-time tells matter how to move. The greater the mass of an object, the more time it will curve. In the black hole, it doesn't occur because it's only one point in the center of a black hole. The gravity is so strong that it also curves the light. According to general relativity, space-time infinitely curved. Studies cannot conclude that there are behind boundaries of black holes or where the matter that disappears with them goes. Matter, according to studies published so far, would fall to such an extent that space-time tissue would break. That point is called singularity, and there would be no physical laws or reality as we know it. Wormhole theory. Two points of the universe are joined by a black hole, known as the Einstein-Rosen bridge. This theory tells us that a black hole could lead us to another dimension that connects two parts of the universe. A shortcut through space-time that leads us to an important term, quantum physics, that develops other theories more like love quantum gravity, which is opening a new paradigm in modern physics. Albert Einstein was a precursor to his theory of relativity. The theory not only described the relationship between space-time, gravity, and matter, but opened the door to the theoretical possibility of a particularly hallucinating phenomenon that would eventually be called black holes.
I will talk to you about two types of black holes. Generally, they have to be four, but no evidence enough about miniature black holes and stellar black holes. These are the common formed from stars 10 to 20 times massive than our sun. Star collapse upon itself, sometimes creating layers into space. If there's enough mass, like gravity, outer core can need to crash it all together density, forming a black hole. Massive black holes. Most have more mass than 1 billion sound. Then suggests of the center of most galaxies. The supermassive black holes at the center of the Milky Way, it's estimated to be about 19.3 million miles across and 4 million solar masses. Some distant galaxies have supermassive supermasses as big as 21 billion times the mass of the Sun. Scientists don't know how they formed or grew to be so big, but it may be closely related to galaxy formation. Conclusions. Let's talk about conclusions. Um, every is not the same based on their size and properties. The study of black holes is not only important for someone who focused on an astronomy career, it helps us broaden our perspective, which is only echo passes at the moment. It's fascinating. It is something that is scientific proven since 1971, when, thanks to Einstein's theory of relativity in the constellation Cygnus, the first black hole was discovered. And thank you for your attention. The last thing that I want to say is that black holes are invisible for human eye. We have to observe them with help of filters. These black holes are too much important for humanity to know how they work, because if we understand them, we can understand all around us. Thank you.